Hello, everyone can hear me? Okay, it's 10 o'clock, so maybe we can start now. So, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everyone. So, welcome to today's webinar on polar tropical links shaping the future of monsoon. So, I am Dr. Amanda, the moderator for today's session. So as we are all aware that the northern states of Malaysia, Kelantan, Terengganu, Pahang are currently experiencing a heavy monsoon rain. So leading to significant flooding in some areas. So 2 days ago, I think there was a viral video that the restaurant Terapung in Kelantan drifted away. And I believe that even today there's more water level rising even in the Klang Valley. So this northern monsoon, which brings persistent rainfall, is expected to continue until March next year. Maybe the two experts today can help to confirm that. But today's session also actually aims to explore the connection between polar regions, Arctic and Antarctica, and Malaysia's monsoon system. So are the changes in these two icy continents influencing monsoon season in Malaysia? Or how does the climate change shape this relationship? So to help us navigate in these important topics, we are fortunate to have two distinguished panelists with us today. So the first is Dr. Shiba Netakundu-Chenoli. She's a senior lecturer from Department of Geography, Faculty of Arts and Social Science, University of Malaya. Dr. Shiba specializes in atmospheric science, particularly in understanding the dynamics of monsoon system and extreme weather patterns. Her research also extends to Antarctic region, where she has examined polar atmospheric interaction and the influence on tropical weather system, including the monsoon. Her work helped bridge the understanding of how polar changes impact global climate patterns, including Southeast Asia. The next we will have Mr. Deong Jo Yi, Senior Assistant Director in Research and Technical Development Division at Malaysian Meteorological Department, also known as MAT Malaysia. Mr. Deong holds a Bachelor of Science Physics from University Putra Malaysia and a Master Marine Science from University Kebangsaan Malaysia. He has contributed to numerous international projects, including the Weather and Climate Science for Service Partnership Southeast Asia. His extensive research focuses on monsoonal dynamics, equatorial waves, and their impacts on the regional rainfall patterns, and several peer-reviewed publications to his name. So without further delay, let us begin with our first speaker. I'm delighted to invite Dr. Shiba to share her insights. Dr. Shiba, the floor is yours.
Thank you very much, Dr. Amanda. Let me share my slide. Okay, I hope you can see, right?
Yes, we can see.
Yes.
Right. So a very good morning to all of you. As you heard from our moderator, Dr. Amanda, my name is Shiba Chenoli, and I'm an academic affiliated with the Department of Geography at University Malaya, and also a research associate at the National Antarctic Research Center at the University Malaya, right? So I'm very thankful to IPSM for bringing this topic, polar tropical linkage, right, under the YPSM webinar series. So this tropical Antarctic teleconnection or tropical polar teleconnection, it holds a particular significance for all of us, especially being a part of maritime continent like Malaysia, right? And this topic also allows us to raise awareness among the public as well as the policymakers to make them understand the importance of Antarctic research. And more than that, Antarctic teleconnection or the polar teleconnection is crucial for improving seasonal climate prediction as well as enhancing our understanding of global climate dynamics, right? So my talk today is organized into 4 main sections. To begin with, I will explain the basic concept of the teleconnection linkages and why it gathers our interest. And also I will explain a little bit on the Antarctic as a continent of extremes, but here we will have a different context apart from the extreme weather conditions there, right? And the subsequent sections will focus on the impact of tropical Antarctic teleconnection and then on the linkages arising from Antarctic influencing the tropical region, right? So this is the overview of my talk. So what is teleconnection? Teleconnections are defined as formally defined as the statistically significant relationship or the links between the weather phenomenon at widely separated location on the Earth, right? So they typically involve climate pattern that can span thousands of kilometers, thousands of miles. And the teleconnection, we can also refer to the climate phenomenon where, very small changes in the atmospheric or oceanic condition in one region of the world can influence the weather and climate pattern in a distant other part of a world, right? So these connections, as I mentioned earlier, you can span thousands of kilometers, and it is usually mediated through large-scale atmospheric or oceanic circulation pattern. So one of the most famous example that we all know is the El Nino Southern Oscillation. The teleconnection pattern associated with the interannual tropical Pacific sea surface temperature variability. That means a very small change in the sea surface temperature in the part of tropical oceans are associated with massive changes in weather globally, right? From Peru to North America to East Africa, Southeast Asia, and also to Antarctic, right? So if you look at the evolution of teleconnection research, over the last several decades, there has been a significant increase in the scientific understanding of the influence of Antarctic climate from the tropic. Right. So if you scan through the earlier research, you will notice that most of the earlier research on teleconnection is associated with the El Nino Southern Oscillation and how it impact on the weather of the polar region, right? The reason for this is that the tropical region is a lot of heat energy is available in the tropical region. So the signature or the signals that is coming from the tropical region is easily recognizable, and we can see how it influences the Antarctic or the polar region, right? And then subsequently, there is a series of studies explored teleconnection that is emerging from Atlantic, influencing the Antarctic weather and climate, right? So most recently, there has been rapid development in understanding the role of decadal scale of sea surface temperature variability in Pacific as well as Atlantic influence the Antarctic climate, right? And because of all this earlier research in the tropical Antarctic connection, this topic has emerged as an active area of understanding the long-term climate changes in Antarctic. So we know that a variability of high latitude also can give some feedback or interaction with the climate conditions at lower latitude, right? So in recent year, there was more attention or more focus has been given to teleconnection that is arising from Antarctic, influence the middle latitude, and also the tropical climate, including the Asian monsoon, right? So majority of my talk will focus on the teleconnection originating from the tropics and influencing the Antarctic. And followed by this talk, Mr. De Jong will, his presentation will explore the teleconnection that is coming from the polar region and their influence on the weather and climate of tropics. So one of the most recognized mechanism of the teleconnection is the stationary Rossby wave. For example, the abnormal sea surface temperature associated with El Nino pattern, right? In the tropical Pacific and Indian Ocean, they are associated with the areas of intense convection, right? So these areas of intense convection can trigger the intense, it can trigger the wave, it can trigger a wave response in the upper level of the atmosphere. We call this as Rossby waves, right? So Rossby wave train consists of alternate areas of low pressure as well as high pressure, as shown in the figure here. And these wave trains can propagate towards Antarctic or other places and can influence the atmospheric circulation over there. So now let us explore the reason why the teleconnection is, this research is of significant interest, right? So this CAR Antarctic Climate Change Environment Report, this highlights the significance of Antarctic climate drivers influencing the Southern Hemisphere climate and then contributing to the climate extremes such as fires and droughts in Australia and as well as the South America, right? So in addition, this report also shows that climate change and variability in the high southern latitude and Antarctic are connected to the lower latitude, including the tropical ocean and monsoon systems, right? So understanding these linkages are critical for improved climate projections as well as enhancing our preparedness for future extreme climate events. And further, this Helsinki Declaration on Climate Change also recognized the critical role of Antarctic and the Southern Ocean in global climate system and the implication of changes in Antarctic to the global climate and sea level rise, right? So, and also various research based on the observation as well as modeling and global assessment shows that there are kind of significant changes in the Antarctic physical and living system, including marine and terrestrial system. And this Antarctic and Southern Ocean environmental changes, they are interconnected and they influence the climate drivers worldwide. So these are the main reason to look at it. And UAE has launched their polar research project recently. They recognize that the melting of Antarctic ice is not only causing the global sea level rise, it is also altering the weather pattern. Indirectly, right? So it is influencing the middle latitude circulation, affecting the Mediterranean and as well as the tropical regions, right? So they also noticed that there is a 36% increase in the formation of the cyclones in Arabian Sea, and there is related increase in the extreme weather over this region, such as flooding, etc. Right? So there was a workshop they organized to launch their program, and they announced the launch of the Polar Research Project recently. Right. So let us look at the Antarctic continent itself, or the changes in the Antarctic continent, right? If you notice, all this Antarctic research talks, right? So Antarctic is always referred to as the continent of extreme. But here, my focus, I'm not referring the extreme weather condition there, but I'm more interested in how the tropical connection from the tropics, which can trigger extreme climate events like extreme high temperature, and how this can lead to the surface melting of the ice shelves and where the temperature can get above freezing point, right? So these events can occur a scale ranging from sometimes it will be like a few days, short-lived events, and then it can have change to decadal to multi-decadal time scales, right? So we will look into that in detail. So here there are some of the examples how tropical variability can trigger short-lived events of extremely high temperature. Example is heat waves, right? And recently, if you look at the records, you can see Antarctica has witnessed notable increase in the extreme heating events, right? And with two of its warmest temperature ever recorded occurring since 2015. So from 2015, there are many heat wave events that is recorded over Antarctic, right? So this highlights the rapid and alarming changes in this region's climate. And two of this temperature, the warmest temperature recorded are given here since 2015, right? So the first event occurred on 24th March 2015, and the temperature over the Antarctic Peninsula rise to a 17.5 degrees centigrade, right? So that time researchers and we thought, wow, that is like really warm event, right? But then just after a few years in 2020, that was surpassed by a heating event of 18.3 degrees centigrade, right? So from that, the records of extreme events in Antarctic, they just kept piling up in the past years. And these temperatures are remarkably warm and they are very important since they are all well above the freezing point, and this can lead to very intense surface melting and also depends on the stability of the ice shelf, right? And you might have heard about this, an unprecedented heat wave in March 2022, right? Where the South Pole has its most severe temperature record. And in East Antarctic, experience a temperature up to 40 degrees centigrade above normal, right? So this shatters all the extreme events or temperature records before that. And it was one of the most intense heat wave ever recorded anywhere in the world, right? So this graph actually shows the daily high temperature at Dom-C in Antarctic, right? And you can see how much the temperature gone up during this event, around 32.5 degree over the Dom-C in Antarctic, right? So we will look into the some of the example of extreme climate variability in the decadal scale, right? So decadal variability refers to the fluctuation in the climate and weather patterns on a time scale roughly 10 years or a decade, right? So this the first figure here shows the surface temperature trend based on the in-situ observation in the Antarctic. You can see before 2000, there is an increase in the temperature, right? So Antarctic Peninsula was considered as one of the rapidly warming place on the Earth before 2000, right? And after that, there is a sudden shift. There was a stop in the or pause in the increase in the temperature, and then there is a rapid, dramatic swing in the multi-decadal variability. And it is going to, after that, it is actually decreasing. The temperature is decreasing, right? So another example is South Pole. South Pole, we thought was, largely isolated from the warming, while the rest of the globe is warming due to climate change. South Pole was actually not affected. And sometimes you can see it is actually, there is a decreasing trend in the temperature, right? But it underwent rapid shift to strong warming after 1980s. So this has been highlighted by consecutive records of high warming year. And again, this is an example of rapid multi-decadal swing in the temperature changes in Antarctic, right? And about the Antarctic sea ice variability, right? So the sea ice variability of Antarctic continues to surprise us as well, because since 1990s, the Arctic sea ice cover has been decreasing. And this decrease has been the part of consistent change in Arctic, including the atmospheric temperatures and warming ocean. It is related to the climate change, increasing the greenhouse gases, right? But the Antarctic situation has been quite different, with the sea ice increasing, sea ice extent increasing overall, and much of the period since 1978, right? And then there is a rapid decrease. You can see from here, right? There is a rapid decrease in 2015, right? So this decrease is so significant that it became the lowest value in the last 40 years, if you look at the 40 years of record, right? So this increase in the sea ice extent have been, far more puzzling than the Arctic sea ice decrease. And this led to various suggestion and explanation from the linkages to the teleconnection or from the tropical influence of tropical Pacific as well as the ozone hole, right? So now we look into the variability of Antarctic sea ice, Antarctic ice sheet as a whole, right? So we can see a strong asymmetry in the land ice changes, the East Antarctic, between the East Antarctic and West Antarctic, right? So West Antarctic ice sheet exhibit significant loss, unlike East Antarctic. So the similar trend is also observed in the sea ice, you can see from here. So moving on to the impact of tropical teleconnection. So we can look into what are the reasons to have these extreme changes in Antarctic. So the driver of the, the unprecedented heat wave in Antarctic in 2022 was an intense tropical convection happened over the this region, right, over the Indian Ocean. And this forced Rossby wave activity. And it also forced to an atmospheric river, right? So atmospheric river are very narrow, long bands of enhanced moisture fluxes originating from the middle latitude and subtropics, right? So they have been associated with high temperature, moisture, wind speed, and sometimes they co-occur with foehn winds. Foehn winds are the warm winds that we can see in Antarctic, especially over the mountain slopes, lee slopes of the mountain, and which can last from several hours to few days, right? So during this event, there was an intense atmospheric river that advected subtropical and middle latitude heat and moisture deep into the Antarctic interior, causing major melt events, which is linked to the instance of sea ice decay, right? So the moisture flux and upper level warm air advection resulting from these, the atmospheric river as well as the foehn wind at the surface eroded the typical surface temperature over the ice sheets, and they causes the unprecedented heat wave over Antarctic, right? So what are the impacts of the heat waves in Antarctic? There was, associated with this heat wave, the Conquer ice shelf, they collapsed, and it coincided with the record heating, right? And it is relatively less common for an ice shelf to disintegrate completely. And also the East Antarctic ice shelf we consider as more stable, right? So in March 22, the Conquer ice shelf collapsed, and the warming event is caused by the atmospheric river appears to trigger this ice shelf collapse, right? So this is one of the impacts of the warming, right? And the warming events in Antarctica is so important because this defined the future of the ice shelf, right? And also, if you look at the history, you can see Larsen B, that is in austral summer of 2002, Larsen C, right? So all this collapse of all this ice shelves was related to the atmospheric river. This actually the collapse is always preceded the atmospheric river, right? So the case studies focusing on Antarctic sea ice retreat illustrate that it is important to not only explore the situation near to the ice shelf, but we also need to consider or explore the linkages between the tropics and Antarctic and the interconnected global climate system to understand more on the sea ice changes occurring in Antarctic. So as I mentioned earlier, most of the 60% of the ice calving, right? Events in Antarctic Peninsula has been triggered by the atmospheric river, as shown by Jonathan Will in 2022. And under the climate change scenarios or future warming projections, it was anticipated that this atmospheric river events are going to increase, and they will move more towards the polar region in the southern hemisphere, and it is going to impact more on the Antarctic weather and climate, right? So before this, we were talking about the sudden rapid events that stays for 1 or 2 days, right? So the teleconnection that is occurring, for longer period of time, right, in the interannual time scale. So one of the important one, as we mentioned earlier, is ENSO, El Nino Southern Oscillation. Right, so the warmer part of the El Nino Southern Oscillation, we call it as El Nino, right, and the positive phase of ENSO, right? So it generates deep convection, and which intensify the Hadley cell, and it can protrude the subtropical jet, generating the stationary Rossby waves, and the Rossby waves can propagate to the Antarctic region, affecting the circulation there, right? So the impact of positive phase of ENSO or El Nino can increase the pressure over the Amundsen Silo area. That is how they interact with the Antarctic weather and climate, right? So Amundsen Silo is a low pressure region over Antarctic. So increasing the pressure over there, that means it will weaken the Amundsen Silo, right? Positive phase of ENSO will weaken the Amundsen Silo. That is how it affects the Antarctic, right? And that was the interannual scale. And on decadal time scale, there is something called Pacific Decadal Oscillation, right? It is very similar to the teleconnection that is generated by ENSO. And in the past 20 years, we can see we are experiencing the negative phase of IPO, right? Where the tropical Eastern Pacific temperature has been decreased. So it is opposite to the teleconnection that is generated by ENSO. So therefore, because of the influence of IPO, the surface pressure around the Amundsen Silo decreased. And that means the Amundsen Silo become deepened, right? And this also, you can see the IPO in recent years is negative. And this also it can also generate Rossby wave that is influencing the Antarctic, right? And there is, other time scales like multi-decadal time scale called Antarctic multi-decadal, Atlantic multi-decadal oscillation, or AMO. So AMO teleconnection pattern originate from the sea surface temperature over the Atlantic region. You can see here, right? And there is a clear oscillation of 60 to 70 years. So in past 40 years, we have had the positive AMO, Atlantic multi-decadal oscillation phase, right? So together with the global warming trend, it leads to rapid warming over the entire tropical and also the North Atlantic, right? So AMO also can trigger the Rossby wave trains, but the difference between the AMO is that the tropical Atlantic area is it is quite close to Western Antarctic. So the stationary waves cannot propagate directly. It can propagate to the east, and then the wave trains generated from the tropical Atlantic have to go around the Antarctic and reach the Amundsen Silo, right? So it is also influencing the Amundsen Silo. So what we have here is IPO, right? That is influencing the Amundsen Silo to make it more intensified or more deepened. And we also have what you call the AMO also influencing the Antarctic region, right? So because of that, the ASL, the Amundsen Silo, is getting more stronger and stronger, right? So let us look at this teleconnection, this schematic diagram to sum up what we can see here, right? So the teleconnection in this recently observed teleconnection is related to climate change over Antarctic. So this intensified the Amundsen sea low, can increase the offshore intrusion, warm offshore intrusion, and also it enhanced the man pumping and also accelerate the West Antarctic melting, right? So Amundsen sea low, as I mentioned, it is a low pressure system, so it is associated with the clockwise circulation over there, and part of it is causing the decrease in the ice over West Antarctic, and also it is increasing the offshore cold wind, right? That is how it is increasing the ice area over the East Antarctic. Right. So as I mentioned, most of the earlier teleconnection was from tropics towards Antarctic, and recently there are many what do you call the research that is coming out to show that the Antarctic also influence the tropical region. The problem with this is like we have to do a lot of analysis because the signals that is coming from Antarctic is always feeble, and it also has kind of interannual variability. So sometimes we will see the relationship very strong, and sometimes this relationship will be not so strong, it will be weak, right? So this is our contribution to show, where we show that the sea ice changes in Antarctic influence the Indian summer monsoon rainfall. That means the high sea ice phase is, during the high sea ice phase, you can see more summer monsoon rainfall, and during the low sea ice phase, there are not so much of influence, right? So this is also related to the meridional wave train, which is enhancing the polar and subtropical jet during the high sea ice phase, and it is doing the other way around or during the low sea ice phase, right? And there are, the colleagues from Brazil identify that the south of Brazil is very sensitive to the explosive cyclogenesis during the intensified tropical Antarctic teleconnection. So we can see the early this year, there was, very bad flood affecting the South America, especially the some part of Brazil. And this is due to the Antarctic Antarctic cold surge that is interacting with the tropical air masses, right? And there is also like explosive cyclones that is affecting Australia, and it is also related with the interaction from the Antarctic weather, right? So these are my conclusions. We know that the global warming and teleconnection will continue to impact on the Antarctic environment and climate with far-reaching and long-lasting consequences, right? And we also know that there will be frequent atmospheric river and heat waves, which will play a key role in the ice shelf stability, right? So Antarctic response to climate change impacting the lower latitude and contributing the extreme will be there. And so these are the gaps in the knowledge so far. And I think I'm running out of time. So thank you very much. I would like to take this opportunity to thank YPSM to, discussing about this topic. Thanks.
Okay, thank you very much, Dr. Shiba, for the insightful presentation. So before we hear Mr. Dion Joying, who will elaborate more on how the dynamics of monsoon are studied and monitored and their connection to the changing polar regions, anyone can feel free to type your question in the chat box for Dr. Shiba to answer at the end of the webinar. So you can just type at the chat box. Okay, so now over to Mr. Dion for his presentation.
Okay, thank you very much. Let me share my screen.
Sure. All right.
Okay. Um, Okay. Thank you very much, Dr. Amanda. And also Dr. Shiba for the nice talk that you have given a while ago. Um, First of all, I would like to thank the Yayasan Penyelidikan Antartika Sutamizan for inviting me to this webinar series, the Climate Talk Apa Kata Pakar. And my talk will be talking about monsoon mainly, especially the monsoon in Malaysia. Okay, what is monsoon? I think when we talk about monsoon, we always talk about rain in Malaysia. I mean, in fact, in anywhere in the part of anywhere in the world, people are talking about when people talks about monsoon, people are associating it with rainfall. So, for instance, in this figure, this is a monsoon cloud arriving in Port Blair in Andaman in India. Because in India, the monsoon play a significant part in their social life. Because in India, there's a huge change from a dry season to a wet season during the arrival of the monsoon. Back home in Malaysia, this is where I got from the NAPMA, our disaster management agency. So when we talk about monsoon, we will immediately think about the northeast monsoon in Malaysia, which is every year. It's a very dramatic event where you have flooding, where you have heavy rainfall, continuous rainfall. So this is what we have. Uh, this is the from the national disaster agencies. So, in a sense, we are telling people to be cautious during the northeast monsoon because of the heavy rainfall and possible flood due to the continuous heavy rainfall. But in the old days, in the histories, monsoon is actually people don't talk. I'm not sure, but we can't we seldom find um, people talking about monsoon associated with disasters, but rather people talks about monsoon with prosperity. Like for instance, if you see the figure over here, uh, the blue color is the spice trade, where traders are utilizing the wind from the monsoon to come and trade, from the west and then from the east, and then they are meeting over in the Malacca Sultanate. So during the northeast monsoon, the Chinese trader will utilize the northeasterly wind and sail to this Malacca region, and then where you have all the spices around the Southeast Asia. And then during the Southwest monsoon, they will sail back to China. I mean, that's what we learned during our history in our secondary schools, I think. So likewise, for traders from the West, from the Arab peninsulas and from India, they will utilize the wind from the southwesterly monsoon to come to Malacca and to trade. So Malacca is the center of the trade in Southeast Asia during the 15th centuries. So at least this is what monsoon in history is in Malaysia. Uh, I mean, we are talking about prosperity instead of linking it with just disasters, heavy rain, miserable weather. So that's in history. So in present days, what is monsoon actually? Like we have said, like what I've said before, the traders are using the wind from uh, the monsoon wind to come and trade. So the word monsoon actually derived from the Arabic term mausim, which is translated as in Bahasa is musim or season. So when it becomes angklat, when you know we and it becomes monsoon eventually, and it is a pronounced seasonal change in wind patterns and precipitation. So we see there's a change in the wind and the precipitation, like I said earlier, from dry season you become wet, and then from southwesterly wind you change into a northeasterly wind. That means wind are predominantly northeasterly during the northeasterly monsoon. Uh, and this is driven by the differential heating of land and ocean surface. I will talk about this a bit later. And monsoon is actually a critical component of the Earth climate system, and it's actually driving the what we call the global circulation, atmospheric circulation. And of course, it plays a significant role in shaping the regional agriculture, water resources, and ecosystem. Um, because like in certain countries, monsoon brings rain, so that's where people are starting to plant. It's a planting seasons, and towards the end of the monsoon is the harvest seasons, and um, and this monsoon actually affects many regions worldwide. In fact, two-thirds of the world population is affected by the monsoon because uh, the two most populous countries in this world is affected by the monsoon, namely the India and the China. So it makes up about two-thirds of the world population. So I was talking about the differential heating between land and sea. So what we can see here is during the summer, where land get heated up rapidly, and the sea, whereas in the sea, it was I mean it got heat up rather slow, so it's cooler than what it's in the land. So when you have a temperature difference, so this is a hot surface, so you have a low pressure, so wind are blowing from high to low, and that's where you have a lot of rain, because where the air is moving out, it's carrying moistures from the seas, and where it forms the rain cloud, and then you have raining. And of course, in the upper atmosphere, it returns to the ocean, and then there's a sinking motion. Where you have sinking motion, you have a rather clear sky, because simply the air, I mean, it's pushing down, so you don't have that. You have that clear sky. Uh, Likewise, during the winter, I mean, contrary, during the winter, the land cools faster than the ocean. So you have a sinking motion over the land, and then you have a um, rising motion over the ocean. So this actually completes this is what we call the monsoon circulation. Okay, I mean, this is just a oversimplified and uh, kind of model to tell you what is a monsoon. And of course, you can also link this with the land sea breeze. But of course, when we talk about land sea breeze, monsoon is like a large scale, a planetary scale of land sea breeze. So in terms of rainfall, you can see the one shaded in green color, it's the southwest monsoon, or the wind, I mean the monsoon in northern hemisphere, or the one in the brown color. This is associated with the rainfall during the monsoon in the southern hemisphere. So this is what we call, the meteorologists call the wind vector. So this is where the wind is blowing. So you can see here the wind is blowing from southwest. So from meteorologists we call this is a southwesterly. Okay. So we can see in India, there's a huge amount of rainfall is dumped during the summer in the northern hemisphere monsoon. Of course, when you flip this down during uh what do you call that, when you have a monsoon over here, so this becomes a dry region. Uh so when this become wet, this become dry. So it's kind of like a interhemispheric difference, depending on which side the monsoon is happening. So of course, this is globally we are talking about. Then we go into regional monsoon. Of course, each monsoon system has a unique characteristics because it's influenced by the geography where the location is. The sea surface temperature, of course, if you are surrounded by the ocean, of course, the monsoons become slightly different from the monsoon where you're surrounded by. I mean, you don't have ocean surrounding the area, and of course, the atmospheric dynamic. So the major monsoon systems are the Asian monsoon, the African monsoon, the North and the South American monsoon. Of course, for our region, we call this Australia-Indonesian monsoon. Okay, in Malaysia, we have monsoon. Strictly, it's influenced by the Boreal winter or Boreal summer. That means um, the monsoon that happens during the winter time in the northern hemisphere, or the monsoon happens during the summer in the northern hemisphere. Okay, so uh, now we are going into the monsoon in Malaysia. So Malaysia is located in the maritime continent. This is where what we call, the meteorologists call this as the maritime continent, because we are surrounded by the uh, the warm seas surrounding the islands and the peninsula. So this region is what we call the maritime continent. And actually, the maritime continent has a very complex terrain. Okay, and then the precipitation is actually the terrain are influencing the where we have the rainfall actually. So if you can see here, the one in warm colors are the rainfall associated during the winter monsoon, or what we call northeast monsoon, and the cold colors are the uh, rainfall that is associated with the summer monsoon. Okay, so we have a higher rainfall during the summer monsoon simply because for the Western Pacific region, this is the region where you have a lot of typhoon, the typhoon path. And similarly, in the Bay of Bengal, this is where you have a lot of cyclone in the Bay of Bengal. So the rainfall variabilities are much higher compared during the winter monsoon. And you can see during the winter monsoon, the heavy rainfall are actually in the southern region. Going back to this figure, so during the winter monsoon means it's a summer in the southern hemisphere. So you have more rainfall. Okay, but we can also expect some rainfall over Malaysia region, simply because the wind are blowing towards the peninsula, and you have terrain here. So it kinds of rainfall is actually facing the windward side of the wind. So which make our region very unique because according to the simple model here again, the rainfall always fall on the summer hemisphere. For instance, this is summer hemisphere, this is winter hemisphere, this is summer hemisphere. So for rainfall, I mean, for monsoon in Malaysia, it's sort of unique because we have rainfall during the winter, in the winter hemisphere. This is the summer hemisphere. So this is simply because it's an interaction between the wind and the terrain in the island. Similarly, for southwest monsoon, of course, why we do not get a lot of rainfall over this region, rather than here, because rainfall, the moisture are being transported into higher latitude during the summer. So which is why for boreal winter we always for north, or what we call a northeast monsoon, because the winds during the boreal winter, the wind are predominantly northeasterly, so we call it a northeast monsoon. uh so it's we always associate northeast monsoon with wet season, whereas during the summer monsoon or the southwest monsoon, where we have a southwesterly wind, we are always associating the southwest monsoon as the dry season, or relatively dry. Okay, so this is just a figure to show that the reversal of wind from the this is a winter season, so this is a northeasterly wind. So you can see that the wind are coming from the continent, the cold continent in this Asiatic region. So it's coming into and then going into the summer hemisphere in Australia. So this is what we call Australian monsoon, which is happening around the northern tip of the Australia region. So likewise, there's a reversal of wind during the summer month, where you have a low pressure. So wind are coming from the high pressure region in the winter hemisphere. As the wind crosses what do you call the equator, because of the dynamics, so it has to turn. So it's the same thing as turn. So this is where you have the southwest monsoon and the northeast monsoon. And during the northeast monsoon, why we have a lot of rain, like I say, because the wind is blowing northeasterly, and then you have what they call a trough. A trough is a low pressure line of low pressure, and then you have this cyclonic vortex, meaning to say the wind are swirling in anti-clockwise. So you have a lot of moisture being transported from the Pacific into our region, and then of course with the terrain, and then sometimes occasionally you have this cold air outbreak from the Siberia High, or what we call a cold surge, cold surges. So these are the northeasterly cold surges, and then because these air are very cold, and when they are traveling along this path towards the region, the underlying sea are warmer, so they pick out the moistures from the warm seas, and then they will dump the rainfall over the northeast, or the or the east coast of Peninsular Malaysia. Of course, during the northeast monsoon, I mean, climatology speaking, in climatology speaking means in terms of the normal the what do you call that, the normal monsoon. What we will get is, during the early part of the monsoon, we will get heavy rainfall over the east coast of Peninsular Malaysia, and then in the mid monsoon, in the middle part of the monsoon, middle period, this rainfall actually got shifted southward, And then towards the end, the rainfall are more concentrated over the Sarawak region, and this region becomes slightly drier, which is why in the early part of the monsoon, you have a lot of heavy rainfall concentrated in Kelantan, Terengganu, and then towards maybe in December, January, you get more rainfall over in Johor, parts of Pang, and then by February, March, you will see more rainfall over in Sarawak. And towards the end of this, you see there's actually no rainfall in the east coast of Peninsular Malaysia towards the end of the northeast monsoon. So, like I say earlier, the monsoon actually is shaping the global circulation, the atmospheric circulation. This is just a schematic diagram of how they are actually influencing the large-scale atmospheric circulation. For instance, this is what we call the southwest monsoon. So you have a branch of air coming in from the southern hemisphere towards the low in the northern hemisphere. So this is what we call, oh, okay. And then you have this circulation coming from the Pacific towards the Pacific into the low in the Asia region. So this is what we call Walker circulation. Walker circulation is named after Gilbert Walker, who has actually found some relationship between the rainfall in India and the oscillations in the pressure oscillation in the Pacific region. And then, of course, this north-south orientation of the circulation is what we call a Hadley circulation. So the Hadley circulation is basically the monsoon circulation, whereas the Walker circulation is the east-west circulation. Of course, you have another branch here in the Indian Ocean. You have another branch of east-west, but we don't call that as a Walker circulation, but we call that east-west circulation. But this east-west circulation is much more weaker than the circulation over here, simply because the basin in the Indian Ocean are smaller, and then there's a land boundary in the northern hemisphere, which is why the east-west circulation is less dramatic compared to the one we have in the Pacific basin. So what actually drives our monsoon in our region? I just did a brief, simple schematic diagram. So we have interdecadal, we have interannual. So intra-seasonal. Interdecadal means that these factors are changing the monsoon in decadal time scales, meaning that maybe for the first 10 years period, the rainfall are slightly different from the next 10 years period or 20 years period. So there is interdecadal. Of course, like interannual is it's different annually, so or from 2 to 8 years. So for instance, like this year, you may get a lot of rainfall in Kelantan, and then probably next year you get rainfall, but not as much as what you have this year. So this is what we call interannual. And of course, intra-seasonal means that it happens within that season. So meaning to say you don't get rainfall, say during the northeast monsoon, you don't get rainfall throughout the season, right? So you get sometimes you get wet season, wet time, and then you get a dry period, and then you get a wet period again. So this happened within that season. So what we call that as intra-seasonal. So the ENSO, like I think Dr. Shiba has talked about ENSO a bit. So ENSO is actually an interannual. It's also influencing the monsoon in our region. The IPO, the Interdecadal Pacific Oscillation also, it's also influencing the, what do you call that, our monsoon in our region simply by, because they have also impact they have some influence on the ENSO. So in turns, it also actually it's affecting the monsoon in our region. So similarly in the Indian Basin, Indian Ocean Basin, we have this Indian Ocean Dipole, which is actually a partner. It's like a partner of ENSO. See, it's almost similar to ENSO. So it has got to do with the oscillation of the warm sea surface temperature between the east-west of the basin. And then, of course, for the polar link, you have this southern annular mode and the northern annular mode, or the northern annular mode is known as the um, Arctic oscillation. Here, some people call this as Antarctica oscillation, Antarctic oscillation. So, this also influence the Indian Ocean Dipole and the ENSO, and there are a lot of studies talk about the southern and annular mode, influencing the rainfall in India. There's a lot of studies has been done in India on this, between the teleconnection between this and the rainfall. And of course, the MGOs is passing over the equatorial region. So it's actually influencing also the weather during that season. So for instance, why we have heavy rainfall during this time, it's because we have the cold air coming from this China region coming into, I mean, I'm talking about what's going on recently. You have cold air coming from the Siberia, okay, here, slightly around this region, bursting. This is a high pressure region, so the air coming down, it's cold and picking up the warm, picking up moisture from the warm seas over this region. And at the same time, now we are in the wet phase of the MGO in what we call maritime continent region. So when you have two extreme meeting together, so you have that big large amount of rainfall coming into our region. So as of this morning, I heard from the news that almost 60,000 people has been evacuated in the Kelantan and Terengganu region. So how does the IPO changes the monsoon? For instance, this is a positive to negative. That means the IPO are moving from positive to negative. So you have a slightly stronger motion, upward motion in the maritime continent, which is why you can get a lot of rainfall during whatever strong upward motion, you have a lot of rainfall. And then when it changes to negative to positive, in a sense, it becomes weaker. So you get lesser convection over in this region. So this is how IPO is influencing the monsoon in the maritime continent. Of course, the southern annular mode, you have this negative phase and positive phase. So this is actually, I think Dr. Shiba has talked about these things, like how the westerly wind are being pushed. When you have more westerly winds in the upper air, it's being pushed towards the equator. This is more poleward. So this is how there's a link between this this westerly, and also how it will affect our monsoon in our region. So, for instance, for a positive SAM, just call it SAM. So a positive SAM, this is a positive SAM, meaning to say that you have low pressure over in the in the Antarctic region. So you have high pressure belt in this region. Okay. So when you have high pressure belt, so this is what we call a mascaron high. So this high, because you have high pressure over this region. So the air is actually, imagine a high pressure. So it's moving into the air can cross the equator stronger. So it brings a lot of moistures to the Indian region, which is why during the positive SAM, you have an increased rainfall in the Indian region. And we know that from our studies, from some previous studies, there's a seesaw pattern between the maritime continent rainfall and the rainfall in India during the summer monsoon. So when you have a lot of rainfall over here, so there's a decrease of rainfall in our region. So when you have a strong cross-equatorial wind during the summer monsoon, we will be getting drier. Of course, during this time it's dry, but we are getting even lesser rainfall during this period of positive SAM. Likewise, for winter monsoon, we have a lot of influence from the northern polar region, which is what we call the Arctic Oscillation. So it can influence the winter monsoon circulation and alter our pattern in the maritime continent. So this is a high pressure. During the negative phase, you have a very high pressure over the Arctic region. So this is the wind. I mean, at the high level, at the high altitude. Yeah. So this is what we call a jet stream. So during this time, when the wind the cold air is being transported into the tropical region. I mean, from high latitude to low latitude actually. So you can imagine that something from above, which is coming down, subsidizing in this region. So the cold outburst will be stronger. So during the negative phase, we have more cold surges. And then when we have more cold surge, we have more cold surges, we have more rainfall in our region. So what lies ahead, in our future? So the future climate change in monsoon region, I mean, of course, it remains quite a high uncertainty with regards to the circulation and precipitation. Of course, we are running climate models, and different models are giving different what do you call that, response. But of course, we try to get consensus from this multi-model. So under future climate scenarios, the northeast monsoon will be slightly weaker because if you are talking about the Arctic oscillation will be mainly in positive phase. Of course, this means that we will get lesser cold surges, weaker intensity in the cold surge, and therefore we will get slightly less rainfall. But then the individual cold surge event may still enhance rainfall in maritime continent. It may, because in a warmer climate, we know that warm air can hold more water. So if the dynamics, thermodynamics are there, so you have more rainfall, it will dump more rain. When it rains, it will dump more rain. So, of course, it may still enhance rainfall in our region, but overall, when we mean the whole season, probably we'll get lesser rainfall in the future. Okay, so with that, I will end my talk here. Thank you very much for listening.
Thank you, Mr. Diong, for your invaluable insight. So I hope today's session has helped us better understand the relationship between polar region dynamics and Malaysian monsoon. I think Mr. Diong mentioned that the pressure and temperature of both region influence our monsoon season here in Malaysia. Yeah. So if you have missed the first half of the session, you can watch it again on our YPSM YouTube channel. Just search YPASM. We believe this knowledge shared by the two experts here today is crucial in facing our increasing challenges of climate change today. So we can now open for question and answer for everyone present in this Zoom platform. You can either raise your hand or just on the mic and introduce yourself. Anybody? No questions? I mean, in the beginning just now, I mentioned that this year's monsoon will be until March, Mr. Diong. Is there any possibility it will be longer than that? Or what is it any different from last year? Or maybe you can give some insight to us here on what to expect the monsoon season this year.
Okay. Okay, thank you very much, Dr. Amanda, for the question. So, of course, the season will be from November to March. But what we are facing now is the early part of the monsoon. And like I say, we have a few series of cold surge happening from last week, this week. That means the cold air coming from the Siberia region. And then coincide also during this time, we have the MGO, what we call the intra-seasonal that is active in it brings whether dry weather or wet weather to our region. And so happen that it's a wet regimes of the MGO in our region. So when we coincide these two events, so we are seeing a lot of rainfall throughout the weekend. If you notice that the rainfall are also spilling over to our West Coast region. So for instance, this morning I heard there's flooding in Klang, right? If I'm not mistaken, and we have some heavy rainfall over the northwestern coast of Malaysia in Penang, in Kedah. So this is well, when we have these two coincide together, so you have more rainfall. But of course, like I say, how towards the end of the season, we will not be getting a lot of rainfall towards the end of the season in Peninsular Malaysia. I mean, at least from the perspective of climatology, that means it will be probably shifted towards the Borneo region towards the end of the seasons. But of course, we are still looking into the models to see how it performs by the end of the northeast monsoon season. Yep. So we will always encourage people to look out for information from our website. Look out for I think we have been blasting I mean, even for this event, we have been issuing the warning since last week. So we hope that people will be vigilant during this time. Okay, that's I hope I answered your questions.
Yes. Thank you, Mr. Diong. So Dr. Shiba, would you like to sum up a little bit? So how does Antarctica influence the monsoon season in Malaysia? Just so that I think some of the people here missed a little bit of your session.
I think you can say from the last diagram that Mr. Diong shared, right? So whenever the mascarene high, it is influence. I mean, mascarene high is a high pressure region over the southern hemisphere, and that is one of the important driver for the southwest monsoon, right? And the mascarene high can get stronger because of many reasons. And one of the reasons that we find out in our research is when the sea ice extend in the Antarctic become more. Some years you can see the sea ice extend is more than normal. So during that time, the mascarene high becomes stronger. And stronger mascarene high signifies a lot of outflow, or the monsoon wind becomes southwesterlies become stronger when the mascarene high is stronger. So during that time, the India will have more rainfall. And as Mr. Diong said, when there is more rainfall over India, there is kind of seesaw effect. So there will be less rainfall over Malaysia. So that is one of the effects that we saw in our research. And we also say that whenever we did some correlation analysis, we also say that there is an influence of sea ice directly to the monsoon over our region, but we haven't, how do I say, we haven't go into that into detail. So that might be our next project to look at how it is affecting the Malaysian region exactly. It's like, what is the direct impact? Yeah.
Okay, we look forward to that and also the result of that upcoming research from you, Dr. Shiba. Okay, before we end this session, let's keep the people of Kelantan, Terengganu and Pahang, the East Coast, in our thoughts and prayers as they navigate this challenging period. I think they're going through a quite hard time with the banjir. So to everyone here, please remain vigilant and take the necessary precautions during the monsoon season. Bawa payung pergi mana-mana. Okay, thank you again for joining us. We look forward to seeing you in the future sessions. Wishing everyone a safe and productive day ahead. Thank you very much, Mr. Dian, Dr. Shiba. Assalamualaikum warahmatullahi wabarakatuh. Thank you. Bye-bye.